Hi everyone, how are you all? I hope you are good. So, today we are back with another video in which today we will be solving the question minimum time visiting all points. So, let's see what is this question. On a 2D plane, there are n points with integer coordinates points I, x, and y. We are given a 2D plane with the points x and y. So return the minimum time in second to visit all the points in the order given by points. So we need to return the minimum time so that we can visit all the points with which we are given in in the order which we are given. Okay. So let's see what are the rules given in which we can move in 1 second, you can either move vertically by 1 unit or move horizontally by 1 unit. Okay, so we can either move vertically or we can move horizontally. So that will be counted as one move. Or we can move diagonally units. So if we move vertically, then it will be counted as one move. If we will move horizontally, then it will be counted as one move. And if we will move diagonally, then it will be also counted as one move. Okay. So you have to visit the points in the same order as they appear in the array. So we need to visit the points in the same order in which we are given. We cannot change the order of visiting the points. Okay. You are allowed to pass the points that appear later in the order, but these do not count as visits. So let's see what is this statement saying. Let's say you are visiting the point A and you need to visit the point A to B. Okay. And then you need to visit the point B to C. But while traveling from A to B, you also passes through C. Okay. But it will not be counted as visited point. C will not be counted as visited point because you have not traveled it in the order in which it is given. You have to travel it after B. If you are passing it through in between some other points, then it will not be counted as visited. Okay, so now let's see how we can solve it. So here you are given these points. We are given with this point is 1 comma 1. Okay. So we are given with this point 1 comma 1 and this point 3 comma 4. We need to travel from 1 comma 1 to 3 comma 4 as you can see here and then minus 1 comma 0. Okay, so let's see how we can travel this. I hope you all have listened about Manhattan distance, which gives the distance required to travel between 2 points, and this distance will be measured in terms of x-axis and y-axis only. But here we can travel along diagonals as well. So Manhattan distance is counted as this x point minus x point of other point plus difference between the y coordinates. Okay, so here Manhattan distance will be 3 minus 1, which is 2, and 4 minus 1, which is 3. So 2 plus 3. Here Manhattan distance is 5. It means 1, 2, 3, 4, 5. Okay, you reach the point 3 comma 4. But Manhattan distance is counted in terms of x and y axis along only. But here we can travel along diagonals as well. So that's the point. So here as you can see that the minimum of x and y, the minimum of absolute distance between these points, giving us the number of diagonals. Okay, number of diagonal travels. Like here the minimum is 2 and we can travel along two diagonals. And then after traveling along two diagonals, it means we have traveled along 2x and 2y. Then we are remaining with one vertical only. Okay, so you can see that here the minimum, here this is giving us the number of horizontal and this is giving us the number of vertical travel. But if you will see that, then the minimum of these will give us the number of diagonal travels and the remaining will give us the number of horizontal or vertical travels. Or we can say that the maximum of this will give us the total number of travels required to reach from this point to this point. As you can see, the maximum is 3 here, and in 1, 2, or third. So in 3 moves, you can reach from my 1, comma 1 to 3, comma 4. Let's talk about another point. It is minus 1, comma 0. Okay, so 3 comma minus 3 minus minus 1, which is 4. 4 minus 0, which is 4. And their maximum is also 4. So as you can see this 1, 2, 3, 4. 4 moves are required to travel from 3, comma 4 to minus 1, comma 0. So we can say that the absolute difference between the coordinates, the maximum of the value of the absolute difference between the coordinates will give us the minimum distance between these points. I hope you get this intuition. Let's try code this. So first of all, we will store the size of the points in n, and we will also initialize the variable result, and then we will run a loop from I is equals to 1 to I is less than n, I plus plus, and we need to travel from points of I minus 1 to points of I, and add that result, add that distance in our result. So we will take the maximum of absolute difference of the coordinates. So points of I of 0, x coordinate of the first point, x coordinate of the second point, and the difference of the y coordinate. This is the y coordinate of the first point, and this is the y coordinate of the second point. And we will take the maximum of both these points differences. And finally, return our result. So let's try run this. Yeah, let's try submitting this. Yeah, it's working fine. So let's talk about the time and space complexity. Its time and space complexity is very simple. As you can see that we are running only one loop from I is equals till n. So its complexity will be O of n, and space complexity will be, as you can see that we are not using any extra space other than these constant variables. So its space complexity will be O of 1. I hope you get this question. This was a very easy question, which is based on very basic maths, which we have studied in our earlier classes. If you still have any doubts, you can post in the comment. I will surely answer them. Thank you for watching this video. Bye bye, guys. See you soon.